We turn our eyes now to the sky with more incredible images from space thanks to NASA's James Webb Space Telescope.
The U.S. quickly shut down the James Webb Telescope after it exposed what NASA was hiding on Mercury. Near our colossal sun, this small planet is anything but ordinary. It dazzles with unexpected treasures, think diamonds, scattered across its fiery terrain. But beyond the shimmer lies a bizarre and enormous core, defying all previous scientific predictions. What untold stories do these astonishing discoveries hold? Stay with us as we expose the revelations that could upend everything we thought we knew about the planet. On the face of it, Mercury might seem like just a speck close to the Sun, but don't let its size fool you. Beneath that scorching exterior lies a trove of phenomenal secrets. Recently, probes from Earth have unearthed a staggering find. Diamonds are liberally sprinkled across Mercury's landscape. Diamonds on one of the hottest planets in our system, and that's just scratching the surface. Delving deeper, we find that Mercury's core is exceptionally large and peculiar. These revelations prompt a burning question: how does Mercury stand apart from its planetary siblings, and what other enigmatic tales might it be keeping under wraps? Mariner 10 was a trailblazer as it was the first spacecraft to visit Mercury. It sent back the first close-up pictures, showing a world full of craters and strange ridges, much like our Moon. This mission revealed that Mercury had a rough surface, a surprisingly strong magnetic field, and a core that was bigger than scientists had thought, challenging old ideas about what Mercury is made of. But that wasn't the most surprising part. The Messenger mission, launched 31 years later, took our understanding of Mercury to a whole new level. Unlike Mariner 10, Messenger was designed to orbit Mercury, allowing it to study the planet in detail over a long period. It captured about 200,000 images, showing us parts of Mercury we had never seen before and deepening our knowledge of this intriguing planet. One of the most interesting findings from the Messenger spacecraft was the discovery of unexpectedly high amounts of calcium and magnesium on the darker side of Mercury. This made scientists curious about the natural processes that might have led to such high levels of these elements. They also found that Mercury's magnetic field was much stronger in the northern regions, which was surprising compared to other planets in our solar system. These findings led scientists to realize that Mercury's internal structure and development were quite different from what they had previously thought. On Earth, magnetic fields are usually created by the movement of molten iron within the core. But Mercury's unique internal makeup causes a different type of magnetic activity. What else makes Mercury's landscape stand out? Besides its craters and ridges, the planet faces extreme environmental conditions. During the day, temperatures on Mercury's surface can reach up to 806 degrees Fahrenheit, hot enough to melt lead. On the other hand, at night, temperatures drop sharply to about -292 degrees Fahrenheit. This huge temperature swing happens because Mercury's thin atmosphere doesn't help much with temperature regulation or heat retention. But the extreme temperatures aren't the only surprising thing about Mercury. More recent studies have uncovered some unexpected features on its surface. In 2012, data from Messenger showed signs of volcanic activity, including evidence of past explosive eruptions. This finding challenged the earlier belief that Mercury was geologically inactive. Then, in 2020, researchers made an even more intriguing discovery. They found water ice in some of Mercury's permanently shadowed polar craters. These areas, always shielded from the sun, are cold enough to keep water frozen, even though Mercury is so close to the sun. The presence of ice raised new questions about whether Mercury might have the potential to support basic life forms. Could there be life forms, similar to those found in Earth's harshest environments, surviving in these icy pockets on Mercury? This question opens up exciting possibilities for understanding how life might endure under different planetary conditions. But that's not the end of the story. In 2018, a spacecraft named Bepi-Colombo was launched towards Mercury, thanks to a partnership between the European Space Agency and the Japan Aerospace Exploration Agency. It's set to reach Mercury by 2025. Once it gets there, Bepi-Colombo will collect detailed information about the planet, including what's on its surface and its geological history. Surprisingly, despite Mercury being so close to the Sun, it has a strong magnetic field and even some water ice. But here's something even more surprising. Mercury has a day that lasts longer than its year. When we think about planets, we usually imagine them spinning on their axis once every day and orbiting the Sun once every year. But Mercury is different. On this small, scorching planet, a single day is actually longer than a whole year. Let's explore Mercury, where a day lasts longer than a year. A symphony of sun and shadow. To put it simply, Mercury takes only 88 Earth days to complete one orbit around the Sun, making its year much shorter than ours. However, one full day on Mercury, meaning one complete rotation on its axis, takes about 176 Earth days. So, a year on Mercury is just half as long as a day. This leads to some very strange effects. If you were standing on Mercury, you would see the Sun rise and slowly get bigger as it moves across the sky. But then, something unusual would happen. The Sun would appear to stop, move backward a bit, and then continue on its way. This strange movement happens because Mercury spins so slowly compared to how fast it orbits the Sun. But that's not the strangest part. Why does Mercury rotate so slowly in the first place? The answer lies in something called tidal locking. Over billions of years, the Sun's gravity has gradually slowed down Mercury's spin. Unlike the Moon, which is fully locked to Earth, Mercury is in a 3:2 spin-orbit resonance. This means that for every 2 orbits around the Sun, Mercury spins 3 times. These unusual spinning and orbiting patterns create extreme conditions on Mercury, especially because of its odd day-night cycle. The side of Mercury that faces the Sun gets extremely hot for months on end, while the side facing away from the Sun remains in freezing darkness for just as long. This leads to some of the most drastic temperature changes in our solar system. When we talk about Mercury's atmosphere, it's important to note that it doesn't really have what we'd consider a true atmosphere. Instead, it has a very thin layer called an exosphere. This layer is so sparse that it constantly escapes into space, and it's only occasionally replenished by things like solar wind, the decay of radioactive materials, and impacts from tiny space rocks.